so the purpose of this video is about negating formulas. The reason why you would ever want to negate a formula is in the future we might ask you to disprove something, whether it be symbolically represented with these symbols or written in plain English. So it's important to know how to negate a statement so you know what it is that you want to prove if you disprove something, because disproving is proving the negation. And so the main idea with this is to put the negation symbol in front of your formula or your statement and then slowly push the negation further in by using these equivalences. Every line should be its own step, so its own use of these equivalences, and every step should be justified by stating one of these. So we'll start off with this example, and this example is not in the lecture. So we're going to negate the entirety of this formula. And we're going to put those brackets around the entirety of the formula as well, because remember, negation bonds to what is immediately next to it. If we just put the negation here without parentheses around the whole formula, we're only negating P and Q. So we've now negated our formula. So now what we want to do is we want to use the equivalences here. And so when we look at this formula here, we have this implication sign, this subformula, and we are negating it. So you can say this is kind of like your alpha, and this is like your beta, and we have negated it. And when we look here, we have this exact same thing here. We have a negation, this is like our alpha, we have the arrow, and then we have like our beta. So this is what we're going to use here. We're going to change this formula into this, but using this here. So to do this, we're going to see the negation goes away when we do this conversion or this replacement. So goodbye negation sign. We're going to write this symbol here, which means logical equivalence for those of you who have forgotten. And then the left-hand side of the arrow remains unchanged. So we have P and Q or P and R. That's unchanged. This arrow turns into a conjunction. And since we're dealing with conjunction and then disjunction, this can present some ambiguity. So it's good practice to kind of put parentheses around the left-hand side. And then the right-hand side of our implication is negated. So this is our right-hand side of the conditional, and the conditional is going to be negated. So we negate P if and only if not Q. Okay. And then we have to state what we used. So this is by this rule that we had just used. It's important to state this not only because it's good practice and it's kind of what is standard, but also to maximize part marks. You might accidentally make a typo, and having this here will allow you to get the part marks from the marker. If you don't have this here, then we don't know what you're doing and we can't give you the part marks. Okay, so when we look here, we still have this negation. This negation is not applied to just an atomic variable. So we have to push this negation further in. So the rest of this formula is just going to be copied over as is. But when we get to this part, now we need to make the changes. So we look here, we have a negation. Here, let me change colors. So it's like we have this negation where P is alpha and not Q is beta. And then we have this if and only if. When we look over here, we have this here. And we actually have two options on what we can do for the equivalences. So I'm going to pick the one that requires the most amount of work. And then you can try doing it with just the other one. Okay, so now we're going to replace with the equivalences. Yeah, this is the right one. So we look here, the negation goes away on the outside. The alpha is going to be the same, so we're going to have P still. The symbol of the double arrow, it stays the same. And now what's on the right-hand side of the double arrow is going to be negated. So we are negating not Q. Okay, and then this is by this rule here. Again, very important to write this. You will lose marks if you forget to write these. And then now we look again and we see, oh look, this negation is not on a symbol, on a variable symbol. This negation is on the negated variable symbol. So we need to further push this in. So again, we are going to copy the rest of our statement. It is going to remain unchanged. And then we see this negation is applied to a not Q. And if we look at our equivalences, there's only one option for us to use. And you'll realize that in pretty much every case, except for the biconditional, there is only one option. So we take the not alpha. Alpha in this case is just Q, and we replace it with just alpha, which would be Q. And then we state that it's by not alpha is equivalent to alpha. And then we could, if we want to, and I'm going to leave this for you to do, a sanity check. And that is, you take this formula here, you have your truth table, and then you take this formula and you put it in the truth table, and you check to see if they're actually logically equivalent. And that's just a good sanity check if you have time on a test or a lab or a quiz or an assignment, just to make sure you didn't do an error on the way. And it's important to put these symbols here, as this is meaning logically equivalent. It's kind of like an equal sign right now, in that it's transitive, right? You're saying this statement is equivalent to this statement, which is equivalent to this statement, which is equivalent to this statement. And because it's transitive, just like an equal sign is transitive, this is equivalent to this. So this is equivalent to this. And now we've fully negated our statement. We did get rid of all of the negation symbols. If we chose this route here instead, though, we would still have negation symbols. We would have a negation symbol at the P and a negation symbol at the Q in our final line. I'll leave for you to try to do that and try to do it from scratch. Yeah, if you have any questions, leave something in the discussion board, send me an email, or ask in office hours. Have a good day.